Hi, this is a supplementary math lesson for Algebra 2, Lesson 77A, what they're calling Advanced Radical Equations. And so, just a quick review, okay, when we have a power above 1 in an equation, even if it's just to the second power or possibly to the third power, it gives us problems for solving problems. And when we have a radical expression, a square root or a root symbol in a equation, it gives us a problem solving that. Let's just review our methods for solving those. So when we have quadratic equations in lesson 38, okay, as we solved here, we can factor out, okay, an x to make this a quadratic equation. Okay, we can factor this trinomial, this quadratic equation, into two factors. Okay, so we have three factors for this original expression, and they equate to 0. Okay, so if we set all of those factors equal to 0, that will give us possible solutions to the problem. Okay, x will equal 0, x minus 5 could equal 0, so that means x, we solve for x could be positive 5. X plus 7 could be 0. If we solve for x, it could be minus 7. We have three possible solutions to that problem. In lesson 39, we said if we have a quadratic equation that is the difference of two squares, the subtraction, the difference of two squares, we can solve that into two factors. They are the, excuse me, the conjugates of each other, the conjugate pair, and we do the same thing. We set each factor, 2x plus 3 equal to 0, 2x minus 3 equal to 0. We get two possible solutions, okay? Minus 3 halves and plus 3 halves. In lesson 48, they said, well, not every time when we have a difference or a binomial or even a trinomial can we factor them as such. So one of the ways that we can solve the problem is we can isolate that variable to the power, in this case to the second power, might be to the third, might be the fourth. Okay, we isolate it. So what am I going to do? I'm going to isolate it, x squared. I'm going to do so by dividing out the 4. I get 9/4. Okay, then how do I get, then I get rid of the power by taking the appropriate root. Okay, I take the square root of x squared to get rid of that squared power. I must do the same to the other side. Now, when they say we do that, when we take the square root of both sides, okay, we must at this stage right here, okay, over on this side of the equation, we put that plus or minus sign, because we'll have two possible solutions when we do that square, that root operation. Okay, we get then x alone on the left side, we get plus or minus the square root of 9/4. Now we recognize we can take the square root of the numerator and the denominator, okay, so it comes out to plus or it comes out to 3 halves. Now look, we have the same solution that we did down here through factoring. Okay, we have a plus or minus 3 halves. Okay, it's important to do that. Now they also said in this lesson 48, we can take advantage of that procedure to isolate a root, or we can isolate a power to a side. Either way, we can isolate the power, the variable to a power, or the variable under a radical symbol. For example, if we have the square root of 4x minus 4 equals 8, okay, if we can isolate that radical symbol on one side, even though there's multiple terms under that symbol, okay, we're isolating everything under that symbol, we can go ahead and apply the operation to get rid of that symbol, just like we did here. We applied a square root. Well, here we're going to apply a square. We're going to square that term, okay, and we must do so to the other side as well. Now, in the case when we square both sides, we don't necessarily introduce that plus minus symbol, okay, at that point. What we do is we take a mental check and we say we must check our answer because the text in that lesson indicated we can get solutions that are not valid for the original expression. Okay, so we must check our answer. I put a check mark there and circle it to remind me I must check my answer. Okay, so by doing so, by squaring this term, what do I get? I get the term inside the radical symbol equal to 64. Okay, therefore x will equal, I bring the 4 over to this side, 68. Is that a valid answer? I go to my original expression. Okay, I'm going to check my answer right here. The square root of 64, or I'm sorry, 68, because x is 68, minus 4 equals 8. The square root of 64 equals 8. 8 equals 8. It checks out. Okay, it does check out in that case. So I can say that my solution then is x equals 68. Okay, so it's the same drill whether we have a power, a variable to a power, or a variable under a root symbol that we can't factor. Okay, the drill is let's isolate that variable to the power. Let's isolate that variable under the square root symbol, which will include everything under the root symbol. Okay, let's apply the operation to either get rid of the power or get rid of the root symbol. Okay, now we're going to go ahead and skip we're going to use the same process, and we're actually going to do one of your homework problems, practice problem A 77. Okay, so let's do that. Now, like I mentioned to you, and I'll be sending out some emails, so some of you have been missing doing your practice problems. You gotta, if there's an A, B, C, D, or the word practice, you gotta do your practice problem. We've been doing those all through the year, and for some reason they've been dropping off here as we've been doing our remote learning. Okay, so now let's look at this problem. This is practice problem A, set 77 on 309. Okay, now we notice they're they're really being tricky now. They're giving us a cube root. It's not just the square root, it's the cube root. But the procedure is valid, okay, no matter what power to the variable. It could be x to the 5th, okay? It could, whatever power of the root, okay? In this case, a cube root. The 3rd root, it could be the 5th root, okay? The procedure is the same. Let's isolate this expression with the variable under the root symbol, and in this case it's a rather long expression. It's that whole thing under the square root symbol. We're going to isolate that on one side. Let's bring everything else over to this side. Okay, then we're going to apply the operation that will get rid of that root symbol, that cube root symbol in this case. How do we get rid of a cube root? Well, we would take the expression and we raise it to the 3rd power. Okay, they do the same thing over here. Raise it to the 3rd power. Okay, that gives us the expression under that root symbol. Okay, if we raise a cube root to the 3rd power, it just gives us the expression under that root symbol. Okay, now over here we have a little bit of math to do, because what this means is we have an x plus 1 times an x plus 1 times an x plus 1. Okay, so we have to multiply this out. Okay, so when I multiply these two terms, I'm going to multiply, distribute these, and then do it again. Okay, when I do that, and I combine, excuse me, and I combine all my terms, I get an x squared plus 2x plus 1. Okay, when I multiply the two x plus 1's together, that's what I get. And then I still have another multiplication to do, another x plus 1. Okay, so again, I multiply the x into the whole expression. I multiply the 1 into the whole expression. When I multiply that out, I combine like terms. Okay, and you guys can practice doing that to make sure you get this same expression: x to the third plus 3x squared plus 3x plus 1. Okay, so when I multiply x plus 1 times x plus 1 times x plus 1 and I multiply it out, this is what I get here. This is what I'm going to get on this side of the equal symbol. Okay. So I notice, what do I have? I have an x to the third and an x to the third on either side. Okay, if I subtracted here and subtracted here, they would cancel out. Okay, quick rule of thumb: if it's the same term to the same sign on either side, they're going to cancel out. Okay, I have a 3x squared positive and a positive 3x squared. Again, they'll cancel out. If I subtract a 3x squared from this side and I do the same to the other side, they'll cancel out. Okay, do I have any others that will cancel out? No, it leaves me a minus 8 equals a 3x plus 1. Okay, and then I forgot to mention, so when I went ahead and applied that to the third power, raising to the third power either side, I must make that mental note. I have to check my answer. Okay, anytime you raise both sides of an equation to powers, you must check the answer, because sometimes they'll return invalid answers. Okay, so going on, I bring the 1 over here, I get a minus 9 equals 3x. I divide out the 3, x could equal minus 3. Okay, so is that a valid answer? I need to check my answer. Okay, now, yeah, I know this is tedious, and do you really need to? Well, in the case when you do raising the power, raising an expression to a power, both sides of the equation, yes, you have to. It's an integral part of the problem. Okay, so what is it going to be? It's going to be the cube root of, I put in x, it's going to be minus 3 to the third power plus 3 times minus 3 squared minus 8 is going to equal, and I'm just, well, let's go ahead and use this, the original term, is going to be minus a minus 3 minus 1. That has to equal 0. Okay? So let's go ahead and do the math. I'll have the cube root of what? Minus 3 times minus 3 times minus 3 is minus 27. Okay? Minus 3 times minus 3 is 9. Times 3 is 27. That's to the positive power. Okay? And then I have my minus 8 under there as well. Okay? I have a minus 3 that turns into a plus 3 minus 1 equals 0. Okay, what will that leave me under my cube root symbol? Minus a negative 8 leaves me a plus 2 over here. Okay, so what is the cube root of minus 8? In other words, what number multiplied by itself 3 times will get minus 8? Well, it's minus 2. Minus 2 times minus 2 is positive 4 times minus 2 is negative 8. Okay, minus 2 plus 2 equals 0. 0 equals 0 checks out. So my x equals minus 3 is a valid solution for that problem. So that is your drill for today. That is how we apply this method to any expression of a power, a variable to a power, or a variable under a square root symbol. The procedure is the same. Let's isolate the term where the variable appears, either like here under the root symbol or with the power, and then we're going to apply the operation to either undo the power or undo the root symbol. In other words, here we had to get rid of the cube root, so we applied a power of 3 to the expression. We raised it to the power of 3 to get rid of that cube root. We do the same thing to the other side. We expand it out. We eliminate or combine like terms. We solve for the problem. Now, when we do that, when we raise to either side, we must go back and check our answer. Okay. Now, I noticed in the book here, half of the time it doesn't check out. So what is your answer? Your answer is no solution. No real number solution to that set. There are solutions in other more advanced areas, but there's no real number solutions. There's going to be imaginary solutions with that I term in it, Euler's notation. We're not covering that in this section. So I hope that helps for today's homework problems. There's one of your problems solved. And give an email or a text message if you have any questions. We're going to be sticking on these types of square root problems all this week. So get prepared for that. Okay, so long for now.